Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 1, Part A says, explain why the gravitational potential near to a point mass is negative. This is a common type of question. You will see this one in many past papers. Sometimes they will ask you to explain why the gravitational potential energy is negative. Sometimes you will see they will ask you to explain why the gravitational potential is negative near a point mass, as in this case. So how we can answer this type of questions? So first of all, imagine that we have a heavy object and the mass of this one is capital M. You can also imagine this is over planet. Now look at me. If I raise this roll of tissue papers, you will see the potential energy is increasing, because in this case work is done by me, so the potential energy is increasing. We can also imagine that we have a unit mass here, so we place small mass here. Now if we raise this one, raise is not important, simply you need to understand. If we move away, we can move away this one from the heavy mass in any direction, its potential energy will increase. So the potential energy will increase. So let's say it is at this point. We can say this point is 1 and this point is 2. We can take another point at infinity. So this point we can take at infinity. At infinity we assume potential is equal to 0. So GPE at infinity is also equal to 0. So now you need to understand what is value of potential at point 2. So value of potential, this has to be smaller than 0. So we can say potential at point 2, it has to be smaller than 0. It means that this has to be negative, and potential at this point, it has to be even smaller than 0. So it means that this one has to be more negative. So we can also say it has to be smaller than 0, means it has to be more negative. So if you go down from infinity, potential or potential energy become more and more negative. So let me draw arrow here. So if we go this way, it becomes more and more negative, and if we go this way, becomes less and less negative. I will say less and less negative, more and more negative. So I'm writing here more. So these are the points you need to understand. So that's the reason potential anywhere below infinity is 0. Potential energy is also 0. We can also write down a general rule for this one. Change in potential energy, this is equal to negative of work done by gravity, or we can generalize, we can say work done by conservative forces. Work done by conservative forces. So work done by conservative forces. Conservative forces, for example, electric force is electric force. So this is net work done by conservative forces. Net work done by conservative forces. Electric force is conservative, spring force is conservative, and gravity is also conservative. So if work is done by gravity, by conservative force, so change in potential energy will be negative. It simply means that if I drop this tissue paper roll, so its potential energy will decrease. But if I do work against gravity, potential energy will increase. So these are the main points you need to understand to answer this type of questions. I hope this makes sense to you. If still it is not clear, you can leave your questions in comments. Now let me show you the answer, how you can write down the answer. This question has 2 marks, so you have to write down 2 concepts, 2 main points. Gravitational force between 2 masses is attractive, so work is done on a mass to move it to infinity. And the second point, gravitational potential is 0 at infinity. Part B says a planet may be assumed to be a uniform sphere. It has gravitational potential phi at distance r from the center of the planet. The variation with 1 over r of phi is shown in figure 1.1. On y-axis simply we have value of potential, and on x-axis we have 1 over r. And r is the distance from center of the planet. Part A says show that the mass of the planet is 8.8 times 10 to 25 kgs. So how we can figure out the mass? First of all, you need to think about what is given to you. So in this case we have graph between phi and 1 over r. So simply we can start with this one. We have phi, this is equal to negative gm divided by r. And if we compare this one, so we can a little bit simplify this. We can say negative gm times 1 over r. Now if we compare this one with straight line equation, y is equal to mx plus c. So in this case c is equal to 0. So we can simply say gradient is equal to negative times gm. So we can write on here gradient in this case is equal to negative gm. So here gm. We need to find out value of mass. So mass will be equal to negative. Mass will be equal to negative. So we have gradient divided by g. Now simply we need to plug in values. So we can rewrite here mass. Now we can choose 2 points on this line. So here we have these 2 points. And here we have value of potential. And here we have value of 1 over r. So value of potential at this point is minus 1.76 times 10 to 8. We have minus 0 divided by. We have value of 1 over r, that is 3.0 times 10 to minus 8. And we also need to divide by value of g, that is 6.67 times 10 to minus 11. This one is here, and this whole has to be multiplied by minus. So we have this minus here. Now if we solve, we will get in this case our answer about 8.8 times 10 to 25 kgs up to 2sf. This is our final answer. So this is how we can figure out. You need to understand for this question, mass cannot be negative. So you need to think about this one. If your answer is negative, you need to figure out why it is negative, because mass cannot be negative. So it means you're missing this negative sign. So that's the reason your answer will be negative, and that is not correct. So you need to understand gravitational potential is always negative. Second part says the period of rotation of the planet is 0.72 Earth days. A satellite in orbit around the planet remains above the same point on the surface of the planet. Use the mass of the planet in B1 to determine the radius capital R of the orbit of the satellite. So in this case, first of all, simply we can imagine we have planet. The mass of this planet is m, and here is one satellite. So this satellite is orbiting around this planet, and these two, they have the same time period. So this is satellite, mass of this one is m. Because this is always above the same point, it means the time period of satellite and time period means time of rotation of the planet is the same. So we can also connect this one. So simply this is telling us if you connect this point on the planet with the satellite, they always stay in front of each other like this. So they go like this, or simply you can imagine they go always like this. It means that they're synchronized, they have the same time period. So value of time period is given to us. Time period is equal to 0.72 times 24 hours, because time of rotation of our planet around its own axis is 24 hours, and 1 hour has 60 minutes and 1 minute has 60 seconds. So this is time period of this planet, and this is also time period of this satellite. The centripetal force in this case is provided by the gravitational force. So simply we can say in this case gravitational force provides the centripetal force. So this is very important sentence you have to write down all the time. Gravitational force in this case provides centripetal force. Centripetal force. Centripetal force is not a force by itself. is just a fancy name for resultant force. So we can say gravitational force provides centripetal force. Gravitational force we have, that is G capital M small m divided by r square. R is the distance between center of this planet and center of satellite. So that is the r. So this r is distance between centers of satellite and planet, and this is equal to mr omega square, and omega is equal to 2 pi over t. So omega, this is equal to 2 pi over t, and t is the time period. So simply we can say this is mr, we have 2 pi, so we can say this will be 4 pi square over t square. Now from here we need to find out value of r. So we can say in this case this mass, this will be cancelled with this one, and if we rearrange this we can write down 4 pi square times r cube. This will be equal to G capital M times t square. So we need to find out value for r, so we can say this will be equal to G capital M times t square divided by 4 pi square. So this is cube. Now simply we need to plug in values. Value of G is 6.67 times 10 to minus 11, and the mass of the planet, it was, we have calculated in part 1, that was 8.8 times 10 to 25, and the time period we have here, so we can say this is 0.72 times 24 times 60 times 60 and square of this, and divided by 4 pi square. So pi square. Now if we simplify this one, so value for r from here we will get about 8.3 times 10 to 7 meters. So this is radius of orbit. So this is how you need to calculate, and this is a typical question as well. You will see this one in many past papers, so you need to be very familiar with this. So this is the main concept. Third part says the speed of the satellite in B2 is 8,400 meters per second. The mass of the satellite is 1200 kgs. Determine the additional energy required to move the satellite from its orbit to infinity. So first of all, simply we can sketch. So here is the mass of the planet. Planet is located here, and satellite is located at this point. Speed of the satellite at this point we have, that is 8,400 meters per second, and the distance from the center of the planet we have just calculated, then r is equal to 8.3 times 10 to 7 meters. Now we want this satellite to move to infinity. At infinity, GPE is equal to 0 and kinetic energy is also equal to 0. So it simply means that initial energy of the satellite, this has to be equal to the final energy of the satellite. So we can say E final. Total energy at this point has to be equal to total energy at this point. So at this point we have GPE, that is G capital M small m divided by R plus, this is negative, GPE is negative, but kinetic energy is positive. So we can say this is 1/2 mv square, but the sum of these two will be negative. So we need some additional energy, we can say that is delta E, and this one has to be equal to 0. So from here we can say delta E, this has to be equal to G capital M small m divided by R minus, this is 1/2 mv squared. So this is the additional amount of energy we need. Now simply we need to plug in values. So value of G is 6.67 times 10 to minus 11. So this is value of G, and the mass of the planet we have, that is 8.8 times 10 to 25, and the mass of satellite is 1200 kgs. and this is divided by distance from the center of the planet, that is 8.3 times 10 to 7, minus we have 1/2 mass of satellite, that is 1200, and speed of satellite is 8400 square. So if we solve this one, we will find energy required, that is 4.3 times 10 to 10 joules. So this is our final. So this is how we need to answer. So the main concept is, if we want this satellite to move from orbit to this point infinity where energy is greater, so here it has negative energy, so here it has greater energy, so we need to give energy to this satellite. So this is the additional amount of energy we need to give to this satellite, so this can reach infinity. And in this case we are assuming there are no resistive forces at all. So this is how we can answer. I hope this question makes sense to you. If you have any questions about this question or from any other papers, please leave in comments and I will try to answer as soon as possible. If you are looking for more resources, please join Patreon. On Patreon you will see more resources. See you next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 4, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question second, part A says, by referring to both kinetic energy and potential energy, explain what is meant by the internal energy of an ideal gas. So first of all, let's try to understand internal energy in a very simple language. So we can say internal energy. Internal energy is the sum of kinetic energies plus potential energies of all the molecules, is the sum of all the random and microscopic kinetic energies and potential energies of all the molecules in a gas. So that is internal energy of a gas. Now how we can define internal energy for an ideal gas? For ideal gases we need to understand there are no intermolecular forces, no attractive forces between molecules. It means that potential energy of ideal gases is equal to 0. So it simply means that internal energy of ideal gas is equal to sum of random kinetic energies of all the molecules in a gas. So these are the points we need to understand. Now let me show you the answer, how you can write down a proper answer. We need to understand all molecules in a gas, they do not have same kinetic energy or same potential energy. Kinetic energy and potential energy, they are randomly distributed. Some have higher kinetic energy, some have lower kinetic energy. So this point is very important, we need to understand. And these points we have to mention in the answer. Now let me show you how you can write on the answer. In the answer you have to mention these points. First of all, we have mentioned it is the sum of all the random and microscopic potential energy and kinetic energy. If this object is moving, it has two kind of kinetic energy. One is the external kinetic energy, mean whole system is moving, whole pen is moving, that is the external. And one is the internal, due to internal kinetic energy it has temperature. So these are two different kinetic energies. So we have to talk about random and microscopic kinetic energy. Microscopic is very important one. For an ideal gas, potential energy is 0. This point you also need to mention. Part B says a fixed mass of an ideal gas at a temperature of 20 degrees Celsius is sealed in a cylinder by a piston as shown in the figure. The initial volume of the gas is 1.24 times 10 to minus 4 meters cube. thermal energy is supplied to the gas and its volume increases by, very important one, understanding of question is very important, increases by, it means this is delta V. So delta V in this case is given to us, that is equal to 5.20 times 10 to minus 5 meter cube. The piston is freely moving so that the gas is always at atmospheric pressure, and atmospheric pressure is given to us. We need to calculate work done by the gas. So work done by the gas, simply work done by gas, this is equal to P times delta V. As in this case it is expanding, so work done by gas is positive. Simply you can use this formula, you can say P times V final minus V initial. If you have the values, if work done by gas is positive, you will get positive result. If you get negative result, it means work done by gas is negative. But when gas is expanding, work done by gas is positive. So for this question we have value of P, that is 1.01 times 10 to 5, and change in volume we have, that is 5.20 times 10 to minus 5 meter cube, and if we solve this one we will get 5.25 joules, and this is positive because gas is expanding. And also this formula is only used if P is constant, so P has to be constant. So they can ask you this question in different ways, so this formula is only valid if P is constant when the gas is expanding or when the gas is compressed. So the answer for this question is 5.25. Second part says calculate the final thermodynamic temperature of the gas, means answer has to be in kelvins. Thermodynamic temperature means absolute temperature. So how we can answer this question? We can simply start from very basic. For an ideal gas, the ratio between P1 V1 over T1, this should be equal to P2 V2 over T2. But in this case P1 is equal to P2 because P is constant. So simply then we can say in this case V1 over T1, this is equal to V2 over T2. And for this question we need to find out value of T2. So we can rearrange, we can write down T2, this one has to be equal to V2 times T1 divided by V1. And value of V2, let me explain you here, value of V2, this has to be equal to V1 plus increase in volume. Value of V1 we have, that was equal to 1.24, and the increase in volume we have, that was equal to 0.520. Actually this is multiplied by 10 to minus 4. So it simply means that V2 we have, that is equal to 1.24 plus 0.520, and this is multiplied by 10 to minus 4, and here we have value of T1. Value of T1 we can also find out. Value of T1 was 20 degrees Celsius, so in Kelvin this has to be equal to plus 273. So it means that this will be 293. So we can also write down here, this is 293 divided by V1. V1 is 1.24 times 10 to minus 4. So simply 10 to minus 4, we can cancel and we can simplify. So if we simplify, the value of T2 will be equal to 416 Kelvin up to 3 SF. So this is our final answer. So main concept is this one. This one is the main concept. Sometimes in the exam they will ask you to prove, is this process obey ideal gas laws or not? And so simply you can start with this equation, you can plug in values. If result is the same, means two sides of equation, if they are equal, it means it obeys ideal gas law, otherwise not. So this is also a very common question in past papers. So physics is about understanding. Physics is different than chemistry, different than bio. In physics, you no need to memorize a lot of things. You need to understand how to apply. Later I will also upload one video how to solve physics problem. I will explain these things in detail. Question says the mass of the gas is 16 grams. For this expansion there is a net transfer of 960 joules of thermal energy to the gas. Calculate the specific heat capacity of the gas at this pressure. So simply we need to calculate specific heat capacity of the gas. We can also understand this one in a better way, so you can visualize. So in this case we have gas, mass of the gas is 16 grams, and temperature of the gas, we have delta T. Temperature of the gas rises from 293 to 416 Kelvin, and mass of the gas we have, and value of Q we have. So in this case we can also write down here the amount of thermal energy supplied to this gas, Q, that is equal to 960 joules. So in this way you can visualize, not just look at the formula, use the formula and find the answer. So you can visualize what is happening. So simply now we can write down Q is equal to mc delta T. We need to find out value of C, so that will be equal to Q divided by M times delta T. Value of Q is 960 joules, and the mass is 16 grams. It means 16 times 10 to minus 3. We have to use SI units, and the change in temperature we have, that is 416. Temperature rises in this case, that is 416 minus 293 Kelvin. This has to be in Kelvin because here the unit is Kelvin. Now if we simplify this one, we will get 490 joules per kg per Kelvin. So this is how we need to answer. So the answer for this question is 490 joules per kg per Kelvin. Part C says the gas in B is allowed to return to its starting temperature. The piston is now fixed in position. Thermal energy is supplied to increase the temperature to the same final temperature as in B. Use the first law of thermodynamics to suggest and explain how the specific heat capacity of the gas for this situation compares with the value in P theory. So in the last part, pressure was constant, but in this case volume is constant, and value of C depends on pressure and also depends on volume. If pressure is constant, value of C will be different, and if volume is constant, value of C will be different. So we call CP and CV. We call CP value of C as constant pressure and value of C at constant volume. So these two values are different. So how we can answer this question? So first of all, in this case we can simply sketch. So this is cylinder, and here we have piston. So this is the piston. Now this piston is fixed. So piston is fixed, it means volume is fixed. And in this case delta T is the same. Delta T is same, so we can say delta T. If delta T is the same for an ideal gas, delta U is also the same. As in this case there is no change in volume, delta V is equal to 0. So it means that work done is equal to 0. So we can use first law of thermodynamics now. Simply we can say delta U, this has to be equal to Q plus W. So in this case delta U has to be equal to Q because work done is equal to 0. And in the last case, so this is the new situation now. In the last case we have delta U that was equal to Q plus W. So we can say this one is Q1 and this one we can say this is Q2. So this is Q2. In this case gas is expanding. Very important point, gas is expanding. As gas is expanding, it means work done by gas is positive, but work done on gas is negative. So it means that delta U, this is equal to Q1 minus W. So from here we can say Q1 will be equal to delta U plus W. You need to understand this is work done on gas, very important one. So in this case delta U is in this case Q1 is equal to delta U plus W. So we can simply say Q1 is greater than Q2. So this is the conclusion from these two processes. So this is the conclusion. This is at constant volume. So this is at constant volume. And this one is taking place at constant pressure. So we can say this is constant pressure. So it means Q1 is greater than Q2. Now we can write down C. C is equal to Q over M times delta T. As in this case, M is the same, rise in temperature is the same. So if Q go down, it means C will go down. So it means in order to raise same temperature, we need to supply lower amount of thermal energy. So new value of C in this case will be lower because Q needed is lower. I hope this makes sense. Now let's try to write down the answer. In the answer we can mention these points. So this is what we have to mention in the answer. So simply we can say same temperature. So it means that same change in internal energy as we have mentioned here. So this point we have mentioned here. Same temperature change, same change in internal energy. As no change in volume, work done is equal to 0. No change in volume, work done is equal to 0. By first law of thermodynamics, less thermal energy is needed. So Q2 is lower than Q1. So new value of C is smaller than the previous value. Question theory says a small object of mass 24 grams rests on a platform. The platform is attached to an oscillator as shown in figure 3.1. The oscillator moves the platform up and down. The total energy of the oscillation of the object is 2.2 times 10 to minus 4 joules. In one oscillation, the object travels a total distance of 14 millimeters. Calculate angular frequency of the oscillations. So first of all, we need to understand the total energy is given. So we can say this is E total. And this is the total distance for one complete oscillation. So it simply means that, let's say object started from equilibrium, it goes to the highest position. So the distance travel is equal to 1 amplitude. Then it come back to equilibrium, it again travel distance equal to 1 amplitude. Then it go down to lowest position. So this distance is also equal to 1 amplitude. Then it come back to equilibrium again. So from here we can say D total, this is equal to 4 times of amplitude. And total distance we have, that is equal to 14 millimeters, means 14 times 10 to minus 3 meters. So we can say amplitude is equal to 14 times 10 to minus 3 divided by 4. So here the unit is meter. Total energy. So the total energy can be equal to, so E total. This can be equal to kinetic energy maximum. So we can say CAIE maximum. This also can be equal to potential energy maximum. But we can use kinetic energy here. So this is easy. We can say this will be equal to 1/2 m V max square. So we can say V max square. So we can say this is 1/2. Here we have m. And V max, we need to understand. V max is equal to A times omega. So simply we can replace Vmax with A omega, so we will get A square omega square. Now simply we need to plug in values. Total energy we have, so we can simply first write down here, this is E total. So we can rewrite once, and now we can plug in values. E total is 2.2 times 10 to minus 4 joules. Here we have 1/2, and the mass is 24 grams. So 24 times 10 to minus 3, so this is in kgs. And amplitude we have, that is 14 times 10 to minus 3 divided by 4 square and multiply by omega square. So here we have omega square. So we can solve for omega square now, and we will get value of omega. So omega in this case will be equal to 39 radians per second up to 2 SF. So this is the final answer. So the main concept is this one. You need to understand, in one oscillation total distance is equal to 4 times of amplitude. You also need to understand total energy is equal to this. Rest is simply plug in numbers and find the answer. Part B says the frequency of the oscillator is fixed and the amplitude of the oscillations is gradually increased. Calculate the maximum amplitude of the oscillation so the object does not lose contact with the platform. So in order to answer this question, we need to understand there are two kinds of accelerations. One is acceleration due to gravity, that is the maximum acceleration of this object, mean maximum downward acceleration of this object is equal to g. But if the acceleration of oscillator downward increase, mean is greater than g, so it means object will lose contact with oscillator. So this is what will happen, like this. So this is the main concept. So we can say as long as acceleration of oscillator is less than r equal to g, object is in contact with oscillator. So this one we can say in contact. And if acceleration of oscillator, this is greater than g, it will lose contact, mean object will lose contact with oscillator. So this is the main concept. Now how we can calculate the maximum amplitude? So simply we can say A, this is equal to minus omega square x. Omega square x. A in this case will be equal to g, the maximum value of acceleration. So this is equal to minus omega square. We can say this one is A. We need to find out value of A. So we will get in this case value of g. This is divided by minus omega square. So we are only interested in magnitude, so simply we can say this is divided by omega square. So value of g is 9.81, and omega value we have calculated, that was 39 square. 39 square because square is here. Now if we solve this one, we will get in this case 6.4 times 10 to minus 3. So this is value of maximum amplitude, and this is how we can figure out. So this is our final answer. So this is the main concept. If this concept is clear to you, then simply you have to use this equation and you can find the answer. Second part says the amplitude of the oscillation is increased, so it is greater than the value in B1. State and explain the position in an oscillation where the object first loses contact with the platform. As we discussed before, the maximum downward acceleration of the object is equal to g. Maximum downward acceleration of this object is equal to g. And when acceleration of oscillator, means the downward acceleration of oscillator is greater than g, it will lose contact. And where this will happen? This will happen at the top of oscillations, not at the bottom. At the bottom, if acceleration is greater than g, it will still stay in contact, and it will lose contact when acceleration of oscillator is greater than g at the top. Mean oscillator will fall down faster than the object, so it will lose contact at the top when the acceleration of oscillator, downward acceleration of oscillator, is greater than g. So these 2 points we have to mention to get full marks, mean to get 2 marks. So one point we can say this will happen at the top of oscillation, so you will get 1 mark, where the downward acceleration of oscillator first exceeds the free fall acceleration at the top and downward. So as we mentioned before, it will lose contact when acceleration of oscillator is greater than g, and this is downward acceleration. So we are talking about here downwards acceleration of oscillator. So this is how we need to answer, and this will happen at top of oscillations, at top of oscillations. Here. I hope this question makes sense. If these videos are helping you to improve your understanding of physics, please like and subscribe, because your encouragement is very important. And if you're looking for more resources, you can join Patreon. On Patreon, you will see full video solutions of past papers and also notes and much more than that. See you next video. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from March 2024, paper 4, variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. In order to get maximum benefit from these videos, or in order to understand physics in a better way, always do questions first of all by yourself. Not only one time, you can try 2 times, 3 times by yourself. So try to understand where do you struggle. In physics, the best way to solve problems are the way we solve problems. First of all, you need to understand the English language. Not only English, question can be in any language. So you need to understand language of the question first of all, what question is. So this is the first thing. So little bit spend time on that and write down what is given to you and what you need to find out. So this is first step. And the second thing is understanding of physics. So then you need to look at the question based on given data and based on what you need to find. You need to use the physics related to that. After that, you have to use algebra, means you need to simplify, and finally you need to do some arithmetic, means basic calculations to find the answer. So in this case, you can see physics is just one part. To master that part, you need practice. So if you practice with understanding, not just always copy from the mark scheme, you will develop your understanding. Because as I often used to say, physics is like a tool. Everyone can have the tool, means everyone can have the formulae and equations. But understanding of physics depends on use of the tool. More you use the tool, more you develop your understanding. For physics, you no need to memorize a lot of things as like in chemistry, bio or other subjects. But for physics, you need only and only understanding. And that understanding you can develop with practice, not just looking at mark schemes. I hope this makes sense, and if you have any questions, you can leave questions in comments about difficulties you're facing to learn physics, and I will try to answer based on the difficulties you are facing in physics. And if these videos are helping you, please like and subscribe, because your encouragement is very important. Let's study together. Let's improve together. Question 4 part A says 3 capacitors are connected as shown in figure 4.1. Determine the total capacitance in microfarad of the network of 3 capacitors. So first of all, when network of capacitors is given to us, we can figure out which capacitors are connected in parallel and which capacitors are connected in series. So if you look at these two capacitors, these two, they are connected in parallel. So we can simply say they are connected in parallel. And then the total capacitance of these two is connected in series with this one. So if I redraw this network, so I will redraw like this. So we have 45. So this one is 45 microfarad. And here we have resultant of two capacitors in parallel. So that one is here, and the resultant of these two, because they are connected in parallel, so it's just like a big plate. Simply you can imagine, let me explain you, just imagine we have two plates and here we have two plates. So simply if you combine, so this become a big plate. So we need to add the capacitance of these two capacitors. So this one is 30 microfarad. So this is capacitor. Now what is the total capacitance? So we will say C total. Now they are connected in series. So they are connected in series. So the C total will be equal to 1 over C total. You can say this is one way to do this question. This will be equal to 1 over 45 microfarad plus 1 over 30 microfarad. So this is one way to answer. As we have only two capacitors, they are connected in parallel. So simply you can say C total, this will be equal to 45 microfarad multiplied by 30 microfarad divided by sum of these two. So we have 40 plus 30 microfarad. Now if we solve this one, we will get 18 microfarad. So this is the final answer. Unit is microfarad, so simply you can say this is 18. Quite straightforward question. So the concept is that when the network is given to you, look at the network, which capacitors are in series and which capacitors are in parallel. Then use the formula and you can find the final answer. Part B says a capacitor of capacitance 45 microfarad is connected to a variable power supply initially set at 8.0 volts. The output of the power supply increases so that the potential difference across the capacitor increases to 9.6 volts. Calculate the increase in energy delta E stored in the capacitor. So first of all, we can simply say the initial energy stored in the capacitor when potential difference across capacitor is equal to 8 volts. That will be equal to 1/2 CV square. So we can say this will be equal to 1/2, and value of C we have, that is 45 microfarad, and value of V is 8 square. And energy final, E final, we can say that will be equal to 1/2 C V square. So we can say this is V initial, this is V final square. So from here we can write on 1/2, here we have 45 microfarad, and here we have 9.6 square. You can also directly do with this one. You no need to plug in values. You can simply use this. With the help of this one, we can simply say delta E, this one will be equal to E final minus E initial. As you can see here, 1/2 C is common, so we can rewrite here, but I'm writing here, but you can simplify this one. So here we have V final square minus we have 1/2 C, this is V initial square. 1/2 C is common, so we can take this out. So here we have V final square, so we can say V final square, and here we have V initial square. So we have V initial square. So here we have V initial square. Now simply we need to plug in values. So we have 1/2 C is 45 microfarad, and value of V final is 9.6 square, and V initial is 8 square. Now if we simplify this one, we will get our final answer, that will be 6.3 times 10 to minus 4 joules. So this is the final answer up to 2SF. So this is the final answer. You also need to keep an eye on the given unit. So this is very important one. Always keep an eye on the given unit. In this case, I have plugged in these values here. You no need to plug in these values here. Simply after this one, you can go to this part and you can simplify, and you will be able to get this answer. If you look at given data, this data has 2SF, this has 2SF, this one also has 2SF. So the final answer can have 2SF or one more. Part C says a sinusoidal AC power supply is connected to the input of a bridge rectifier. The output of the rectifier is connected to a load resistor. Complete the circuit in figure 4.2 by adding a capacitor to smooth the PD across the load resistor. To smooth the PD across this load resistor, capacitor should be connected in parallel with load resistor. So this is the first thing you need to understand. It has to be connected in parallel. So we can connect our capacitor here, but you cannot leave this circuit open. You have to close this circuit. So you need to draw the line here as well. So you need to close the circuit. So this is also very important one. You have to close the circuit. This should not be open. So if you draw this one in parallel and circuit is closed, you will get 1 mark. Second part says the variation with time t of the PDV of the smoothed output is shown in figure 4.3. Determine the time constant in milliseconds of the smoothing circuit. Actually, this is asking us to calculate the time constant of capacitor. Now, if you look at this given figure, at this point we have maximum value of PD across capacitor, and then this capacitor will discharge because the PD across capacitor and PD across resistor will be the same because they are connected in parallel. So at this point, value of PD we have 4, so this is 4 volts, and time is 5 milliseconds. At this point, value of PD is 3.2 volts, and value of time we can find out. Value of time from here we can find out. So here is value of time, so this is 13 milliseconds. So we can find out discharging time from this point to this point. So we can say delta t, that will be equal to 13.0 minus 5, so this is equal to 8.0 milliseconds. And value of potential we have 4, then is 3.2. Now simply we have to use discharging formula for capacitor. V mean at any given time, this is equal to V naught, the maximum value of V, times e to the power of minus t. This is the discharging time over tau. So this is the time constant. We can plug in values here. We have value of V across capacitor after 8.0 milliseconds, that is 3.2. Initial value is 4. So here we have e to the power of minus 8.0 divided by tau. As this is in milliseconds, so value of tau also will be in milliseconds because value power of E has no units. So this one has no units. So no units. So if the unit of this one is millisecond, unit of tau also will be millisecond. So this is the key concept you need to understand. Now from here we can simplify. We can say this will be 3.2 divided by 4. This will be equal to e to the power of minus, here we have 8.0. This is in milliseconds divided by tau. Now if we take ln on both sides, so we can say ln here, this will be 3.2 divided by 4, and if we take ln on this side, ln e is 1, so here we will get minus, this will be 8.0 divided by tau. So we will get here. Now we can solve for tau, and value of tau in this case will be equal to 36 milliseconds. It cannot be less than 8, because time constant is longer than this discharging time. So time constant is longer than discharging time, so this has to be true. So this is the point here. So if you have done these points, you will get 3 marks for this question. So here we have 36. Part D says a sinusoidal AC power supply has a maximum power of 16 watts. State the value of the mean power when the output of the power supply is full wave rectified. So we can simply sketch first of all full wave rectified. So this is full wave rectified. So this is full wave rectified. In this case, the maximum power is given to us, that is equal to 16 watts. So we can draw the line here. So this value is given to us, that is equal to 16 watts. So how about the mean power? Mean power of full wave rectified signal or the mean power of AC power supply, that has to be equal to half of the maximum value, 1/2 of P max. So P max. So we have 1/2 and here we have 16. So we will get 8.0 watts. So this has to be 8.0 watts. Now it is given to us is half wave rectified. Half wave rectified means that the signal we will see, it will look like this. So we will see again here power, half of the cycle there will be no power. So in this case, what is P mean? In this case, P mean. So in this case, for this one, we will have average power. That one will be 8 watts. So we can say this one will be 8 watts. But this half of the cycle, we have no power. Half of the cycle we have power, half of the cycle we don't have power. So it means this has to be 8.0 divided by 2. So we will get 4.0. So this one has to be 4.0 watts. If it is half wave rectified, mean half of the cycle no power, half of the cycle we have power. So it has to be divided by 2. Or simply you can understand, this is another way to understand. P mean, this has to be equal to 1/4 of P max if it is half wave rectified. So we can say for half wave rectification, so half wave, so important point to understand, half wave rectification. So we can say for half wave rectification, and for full wave rectification we can say P mean, or for AC power supply this has to be equal to 1/2 of P max, and this is for full wave rectification, full wave rectified signal, and this is also for AC power supply, so we can say AC power supply. So these are 2 important points you need to keep in your mind to answer this type of questions in future. I hope this makes sense, and that's all for today's video, and remaining questions I'll be uploading as soon as possible. If these videos are helping you, please like and subscribe, because your encouragement is very important. And also, if you are looking for extra resources, you can join Patreon. On Patreon you will find a lot more resources. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 5, Part A says, an object travels in a circle at constant speed. State the names of 2 quantities that vary during the motion of the object. So in this case, it is given to us speed is constant. So how about velocity? Direction of velocity. Velocity is a vector quantity. It has direction. Velocity is
vector quantity. It has direction. So when the object is at this point, its direction of velocity is this way. So this is direction of velocity. When the object is here, direction of velocity is this way. When object is here, direction of velocity is this way. So you can also say at this point it is pointing to the right. So direction of velocity changing, so it means velocity is changing. So we can say one quantity that is changing is velocity. Now we can also think about momentum of this object. Momentum is equal to m times v. We can also say momentum p, this is equal to m times v. V is a vector, momentum is also vector. Momentum and velocity, they have same direction. These two quantities, they have same direction. As in this case, direction of velocity is changing. It means direction of momentum is also changing, so momentum is also changing. So we can write down the second quantity, that is momentum. So momentum keeps on changing during this motion. We can also talk about angular displacement. So here we have angular displacement. So here you can say angular displacement. Angular displacement of this object also keeps on changing because its magnitude keeps on changing. So you can also say angular displacement. You can also talk about the force, because when object is at this point, direction of resultant force on this object is this way. So this is direction of force. When object is here, direction of force is down. So we can say direction of force is in this way. Direction of force is in this direction at this point. Direction of force is upwards. So force is also changing. Resultant force, mean the centripetal force in this case, also keep on changing. So if you write down these two quantities, you will get 2 marks. Part B says a charged particle of mass m and with charge q enters a region of uniform magnetic field perpendicular to the field lines. The magnetic flux density is P. It's very important, perpendicular to the magnetic field lines. If perpendicular, it means that it will only do circular motion. If not perpendicular, so the path of particle will be helical path. So this is very important one. When you read question, you need to understand, is the particle entering the magnetic field is perpendicular to the magnetic field or not. It is also given to us the particles travels in a circle with period capital T, mean time period is equal to capital T, and radius is r, by considering the magnetic force acting on the particle. So this is kind of hint for you, magnetic force acting on the particle. So we can sketch first of all. So simply you can imagine, you need to visualize this one. So we can simply imagine this one is magnetic field. In this case, particle is moving along this line. Now simply you can say the charge is not given to us, means the sign of the charge is not given. So simply we can imagine this is particle, charged particle. As this particle will enter this magnetic field, this will do circular motion, and radius of this circle is given, that is equal to r. So now we need to understand why this particle is moving in a circle, because in this case centripetal force is provided by magnetic force. So we can start with this one. In this case, magnetic force is providing the centripetal force, and magnetic force is QVB, and centripetal force is mv square divided by r. So from here we can cancel this v with this one, so we left with v is equal to r qb, and this is divided by m. But this is not the answer. We can also rearrange this one. We can say b in this case will be equal to mv divided by r times q. But this is not the answer. So in the answer, if you look at the answer, v is not in the answer. So we can write down v in terms of other quantities. V is the orbital velocity, mean the time orbital velocity of this particle, and that one will be equal to the total distance traveled by this particle in one circle divided by time taken. So V is equal to 2 pi r over capital T, because we need time period in our answer, so that's the reason we have to use V is equal to 2 pi r divided by T. Now we can simply replace V with this, so we have here M, we have 2 pi r, and this is divided by Q times R. Q times R. So this R we can cancel with this R. We also have T here. So this is the T, mean this T here. Now if you look at this one, so we got simply 2 pi M. This is divided by Q times T. So this is how you need to approach the problems. Everything is given to you. You need to understand how to proceed in a very systematic way. So this is our final answer. Question was asking us to show that B is equal to this one. So this is our final answer. Second part says the particle is an alpha particle. The period of the circular motion is 2.5 microseconds. Calculate B. We have already equation for B. So first of all we can write down B. This is equal to 2 pi M divided by Q times T. So in this case 2 pi, this is constant. So we need mass of alpha particle, and mass of alpha particle, this is equal to 4u. 4u means that this is 4 times 1.66 times 10 to minus 27 kgs. 1u is equal to 1.66 times 10 to minus 27 kgs. And the charge on alpha particle is equal to 1.60 times 10 to minus 19, but this is equal to 2 times of the charge on single electron. So we have to multiply this one by 2. Now simply we need to plug in values here. We have 4 times 1.66 times 10 to minus 27 kgs divided by the charge on alpha particle, that is 2 times 1.66 times 10 to minus 19 multiplied by time period, that is 2.5 microseconds, 10 to minus 6. Now if we simplify, in this case we will get value of B, that is equal to 0.052 Teslas. So this is our final answer. So this is how you need to approach. Third part says a second alpha particle is in the same uniform field. It travels in a circle of radius 2r. State and explain how the periods of the motion of two particles compare. So in this case we have two alpha particles. They are in the same magnetic field. Same alpha particle means same mass, same charge, and same value of B because they are in the same magnetic field. Now if you look at this equation, we have already derived in the last part, and if we rearrange this one, we can say T will be equal to 2 pi M divided by Q times B. In this case Q is the same, B is the same, M is the same, so it means time period for these two particles is also the same. This is straightforward way to answer this question. Now let's try to understand this one in a better way so you can clear your concept. So imagine that this is one circle, one alpha particle is moving in this one, and second alpha particle is moving in this circle. Radius is 2 times, so this radius is 2 times. So simply we can draw like this. So the first alpha particle has radius r, is moving in this one, then second alpha particle is moving in this circle, and this radius is 2r. Now if we start, in this case magnetic force is providing the centripetal force, so we can start from here. Magnetic force is providing the centripetal force, and magnetic force is QVB. This is equal to mv square divided by r. So in this case this v we can cancel with this v, so we left with v, that will be equal to QB times r divided by m. So in this case m is the same, q is the same, b is the same. So if r is double, how about the speed? Speed also will be double. As the speed is double, now we can write down v, means the orbital speed, this is equal to 2 pi r divided by capital T. So if this increase, this also increase, so it means this remains same. This increases by 2 times, this also increases by 2 times. It means time period is independent of r. So this is the point you need to understand. I hope this makes sense. Now let me show you how you can write down the answer. You have to write down simply 2 points. First of all, you have to state, means you have to state, very important one, you have to state same, so that when examiner will mark your paper, examiner will see that have you stated or not, you will get marked for that. And second, you have to explain. So if you have written T is independent of R, you will get 1 mark for this question. Part 4 says the speed of the alpha particle in B2 is 1.1 times 10 to 6 meters per second. An electric field is applied so that this particle now moves with constant velocity. Use your answers in B2 to calculate the electric field E. Give the unit with your answer. So it's very important one, constant velocity, because many students they will be struggling with this one, how to answer this question. Constant velocity is given to you. So what is meaning of constant velocity? It means direction of motion is constant and magnitude of velocity is also constant, means speed is also constant. So what kind of motion we can expect? If velocity is constant, it means particle is just moving in a straight line. Particle is moving in a straight line. So first of all, just imagine that we have magnetic field, so this is representing magnetic field into the page. If no electric field, particle will do circular motion as we have discussed in the previous part. But in this case it is given to us, this particle just go in a straight line because its velocity is constant. And this is only possible because in this case the magnetic force on the particle, if it is only in the magnetic field, force on the particle will be in upward direction. Now in this case particle is moving with constant velocity. It means that this force is balanced by electric force. So the force, if this particle is positive force, electric force on this one has to be down. It means this side, this plate, this one is positive and we can attach one plate here. This plate is negative. So electric field is pointing in downward direction. So we can draw some electric field lines here. So these are representing electric field lines. So this is what is happening, and this is simply velocity selected. So in this case simply you can say magnetic force is balanced by electric force, and magnetic force is QVB and electric force is E times Q. We need to find out value of E. So this Q will be cancelled with this Q, so we left with E, that is equal to V times P, and value of V is given, that is equal to 1.1 times 10 to 6, and value of B we have found in the last part, that was equal to 0.052. Now if we solve this one, we will get 5.7 times 10 to 4, unit is newtons per coulomb. So this is our final answer, 5.7 times 10 to 4, and the unit is newtons per coulomb. And this is the answer. And that's all for today's video. I hope this video was helpful. I have a little bit problem with my throat, so I tried my best to explain to you in a very simple way and also try to explain you in detail so you can improve your understanding of physics, not just memorize. If this video was helpful, please like and subscribe and also share with your friends, and more videos are coming soon. And if you need extra help, you can also join Patreon. On Patreon you will find more resources. See you in next video.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. In order to get maximum benefit from these videos, always try questions first of all by yourself. It doesn't matter whether your answer is correct or incorrect. What matters is whether you have tried or not. When you try to answer the question, it helps you to understand your misconceptions and also it helps you to realize your weakness. And that is what is most needed for understanding of physics. When we figure out our misconceptions about any topic, then we can improve our understanding. So always try questions first of all by yourself, not just simply look at the mark scheme or simply look at the solution. To improve your understanding, your own efforts are very important. So always try first of all by yourself. Let's study together, let's improve together. Question 6 part A says, a small coil C has 64 turns and cross-sectional area 0.71 centimeter square. The coil is placed inside a solenoid as shown in figure 6.1. So coil C is placed here. The center of coil C is on the center axis of the solenoid. There is a constant current in the solenoid. Coil C is moved through the solenoid from position X to position Y. On figure 6.2, sketch a line to show the variation of the magnetic flux linkage in coil C with position as it moves from X to Y. Means when we move this coil C from X to Y, what is the change in the magnetic flux linkage? So first of all, we need to understand magnetic flux linkage of coil C. So magnetic flux linkage of coil C, this will be equal to the number of turns of coil C, cross-sectional area of coil C, and the value of B, magnetic flux density. As this coil is placed inside solenoid, so the value of B is constant. Magnetic flux density means the magnetic field inside solenoid is constant. So we can say inside solenoid value of B is constant. So this is the main concept you need to understand. Inside solenoid B is constant. So this is the main concept. So inside solenoid magnetic field is constant, mean magnetic flux density is constant. So it means this quantity is constant, cross-sectional area of this coil is constant, and number of turns also constant. So it means that flux is constant when we move from X to Y. So it simply means that we need to draw horizontal line. You can draw anywhere. So simply you can draw one horizontal line. If you have drawn this one, you will get 1 mark for this question. For the second part, we need to explain the shape of line in part A1. We have already discussed why we draw the horizontal line. So now you need to explain why you draw the horizontal line. We have already discussed that point, so simply I will write again. Magnetic flux linkage for coil C, that is equal to NBA. So NC is constant, BC is constant, AC is constant. So magnetic flux linkage through coil C when we move from X to Y, that is constant. So you need to write down these points. So simply you can say in this case, the first point you can say is constant flux density inside coil. Flux density simply we are talking about B. Then flux is equal to BAN, means the flux linkage. B is constant, E is constant, and N is also constant. So if you have written first point, you will get 1 mark, and for the second one, you will get the second mark. So this is how these 2 marks will be awarded. Third part says coil C is now held stationary at X. The current in the solenoid varies so that the magnetic flux density B at X varies from time t equal to 0 to time t is equal to 40, as shown in figure 6.3.
calculate the magnetic flux, calculate the maximum magnetic flux linkage in coil C. Maximum magnetic flux linkage. We have already discussed that magnetic flux linkage through coil C, that is equal to number of turns of coil C, cross-sectional area of coil C, and value of P, magnetic flux density. Magnetic flux density. So in this case, N is constant, AC is constant. So when this value will be maximum, so this value will be maximum when B is maximum. When B is maximum. So when B is maximum, so if you look at this given graph, here B is maximum. So this is maximum value of B. Now simply we need to plug in values. So we have N number of turns of coil C, 64. Cross-sectional area was given to us, that was 0.71 centimeter square. So we need to understand 1 centimeter, this is equal to 10 to minus 2 meter. So we have square, so we have to square these both sides. So we can say in this case 1 centimeter square will be equal to 10 to minus 4 meter square. So we have to multiply this one with 10 to minus 4. And B is maximum, and its value is equal to 0.080. Now if we solve this one, we will get 3.6 times 10 to minus 4 Weber. We will get, this is the answer, Weber. So simply you can write down up to SF, because our data, given data has 2 SF, so the final answer also should have 2 SF. So we can say 3.6 times 10 to minus 4. Unit is already written here. So if you have got the right answer, you will get 2 marks for this question. And if your answer is wrong, for example, you got this wrong answer, but you have written formula and you have written these values, still you will get 1 C mark. Part 4 says on figure 6.4, sketch a line. Sketch a line. It doesn't mean that you need to sketch a line. It means you need to sketch a graph. So don't get confused with this sentence, means with this language. Sketch a line means sketch a graph. Sketch a graph. It can be a curve, it can be a straight line. To show the induced electromotive force E in coil C from time t equal to 0 to t is equal to 4t. So simply we need to sketch a graph between induced EMF in coil C against time. So first of all, let's try to understand induced EMF. This is equal to negative of d phi by dt. So now simply we can say we have d, and magnetic flux linkage, this is NBA. So this NBA divided by dt. So in this case, N is constant, A is constant. So simply we can take these two quantities out. So we can say this is negative, we have N, and here we have A. And here we have dB by dt. dB by dt. So we can also simplify. We can replace these two quantities with one constant. So we can say, let's say this is K is a constant. So here we have dB by dt. And dB by dt, if you look at this graph, B against t, dB by dt is simply, this one is the gradient of BT graph. So this is gradient of BT graph. That's all. So we need to look at the gradient of this. Here gradient is equal to 0. It means until t is equal to 0, means from here to here t is equal to 0. So it means this value is equal to 0, because gradient 0, it means EMF is equal to 0. And now if you look at the second one, second part here, this gradient is positive, but here we have this negative sign, this minus sign. It means that negative, so it means EMF, this one is positive, so the EMF has to be negative. So we can draw here. We don't have the exact value, so simply you can draw here because the scale is not given to us, so simply we can draw the line here. Now we need to compare the gradient. From here to here, you can see along time axis we have two small squares. Along the axis we also have two small squares. Now if you look at the gradient of this one, in this case we have 1 2 3 4, means 4 small square along time axis, and also we have 1 2 3 and 4, and also 4 small square along B axis. So it means gradient of this part and this part is the same, but this gradient is negative, so EMF has to be positive. After time 2t, EMF has to be positive, so it has to be positive from here to 4t, so 4t. So this is very important. So these two gradient, these two values means the value of induced EMF here and value of induced EMF here has to be the same, because gradient is same and we have constant here, this constant is also same, so it means EMF is the same, but the sign polarity has to be opposite. If you draw this one positive, you can draw, that is also acceptable, then this one has to be negative. If you have drawn this one negative, this one has to be positive, but magnitude should be the same. So this is how simply you can draw. Part B says a metal spring rests on a smooth table. The turns of the spring are equally spaced. The ends of the spring are connected to a DC power supply as shown in figure 6.5. The spring is connected to the DC power supply using flexible leads. The spring is not under tension. With reference to magnetic field, describe and explain the change in the distance between the turns of the spring when the power supply is first switched on. So first of all, simply we can imagine power supply is connected here, so we can say this side is positive and this side is negative. So in this case, current will flow like this. So here direction of current is up, here direction of current will be down, and here direction of current will be up, here direction of current will be down, and so on. So one thing you can see from here, current in each coil flow in the same direction. So if we simply draw one turn here and if we draw another turn here, you can see current here is up, current here is down, current here is up, current here is down. So current in same direction, so we can say same direction of current in each coil. In each turn, you can say, or simply you can say in each coil. Now you need to understand, if we have two wires, very basic concept, if we have two wires, current flow in the same direction, so these two wires, they will attract each other. So they will attract each other. So simply we can say they will attract. But if current flow in the opposite direction, so means current in one wire is up and in other wire current is down, they will repel each other. So this is very basic concept. Even we have studied this one at IGCSE level. We can also use Fleming left hand rule and we can prove this one. But for simple understanding, you need to understand wires they will attract and when they will repel. And same is true for the coils. Current is up, then is down. So simply you can say current is up, then is down. So direction of magnetic field, let's say here I'm just drawing one here. Let's say this pole is N, this pole is S. So the pole here, this is just for reference. So this pole has to be N, this pole has to be S. So current flow like this. So I'm saying if the coil is placed like this, so this is coil. So this side will be N, that side will be S. So from my side, so coil is a loop like this. So I'm saying coil is like this. So you can simply see. So this is here. So current here is up, and this side is down. So thumb is pointing to the left, so it means left side will be north pole. So this pole is S, this is N, so they will attract. So it means these two coils, they will attract each other. So that's the main point you need to understand. So this is the basic concept. This is basic concept. So this is what you need to understand. So these two turns means each turn they will attract each other. So they will get closer and the distance between turns will decrease. And this question is a common question in past papers, and this is kind of tricky question. So you need to master this one. What is happening here? If this is clear to you, maybe in your coming exam you will see question about this concept. So try to master this one. If you have any questions, you can leave your questions in comments and I will try to answer as soon as possible. And if you are looking for extra resources, you can also join Patreon. On Patreon you will find more resources. Now let me show you how you can write down the answer. To answer this question has 3 marks, so you can write about these points. First thing you can say, current in spring creates a magnetic field around the spring. As we have discussed here, current in the coil, current in each turn, it produces its own induced magnetic field. Magnetic fields around adjacent turns interact to cause an attractive force to be exerted between the turns. So we can say cause an attractive force to be exerted between the turns means they attract each other, simply you can say, and distance between turns decreases. Question was asking you to describe and explain. So in this case you can say distance will decrease because current will cause induced magnetic field in each turn, and magnetic fields of two adjacent turns, they will attract each other, so they will be attractive force. Mean due to interaction between magnetic field there will be attractive force and the distance between turns will decrease. So very simple concept. So you can say in current, so you can also write down like this: current produces induced magnetic field, or simply you can say induced magnetic field in each turn, or you can say simply induced magnetic field. So I'm just writing in detail, and that cause attractive force between turns and distance decreases. So this is the main concept. So distance decreases. So this is what you need to understand. I hope it makes sense. That's all for today's video, and remaining questions I'll be uploading as soon as possible. If these videos are helping you, please like and subscribe, and also share with your friends. If you like and subscribe, that is kind of encouragement for your teacher. See you in next video.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 7 part A says, a photon has an energy of 3.11 times 10 to minus 19 joules. Calculate the momentum of the photon. So energy is given to us. Now we need to relate this energy with momentum. So how we can relate? So first of all, we need to understand energy of a photon. This is equal to hc over lambda. This is energy of single photon. And momentum is equal to h over lambda. So you can see from here, h over lambda, this is momentum. So we can say from here, E is equal to P times C.
We need to calculate momentum, so simply momentum in this case will be equal to E divided by C. C is a constant. Value of E we have, this is in joules. So you need to look at this one. This energy should be given to you in joules. If this is given in electron volts, as most of the time you will see in the question, energy will be given in terms of electron volts, mean in units of electron volts. So you have to convert that into joules. In this case, already energy is in joules, so simply we can write down 3.11 times 10 to minus 19 joules, and C is a constant, that is equal to 3.0 times 10 to 8 meters per second. Now, if we simplify this one, in this case, we will get value of momentum that will be equal to 1.04 times 10 to minus 27. Minus 27. So you will write on here 1.4 times 10 to minus 27 newtons second. So this is our final answer. Pretty straightforward one, but these two equations are very important for quantum physics. Part B says a laser beam has a power of 350 milliwatts. The light from the laser has a wavelength of 640 nanometers. Determine the number of photons emitted by the laser in a time of 1 second. In order to answer this question, simply you can start with power. Power is equal to energy over time. Energy over time. So we can say this is energy over time, but this is not very clear. Energy is not the energy of single photon. Here we are talking about total energy of laser. Total energy emitted by the laser in given time. So we can say given time. And total energy will be equal to the number of photons times energy of single photon. Like this, you need to understand physics, divided by time. So in this case we can say time is t. So value of P is given, so simply we can write on here first of all P, this is equal to E. I will be writing P here, means energy of single photon divided by time. So we need to find out N. So N in this case simply will be equal to PT divided by energy of single photon. So we can say energy of single photon. So what is value of P? Value of P is 350 milliwatts, 10 to minus 3 watts. And the value of time is 1 second. And energy of single photon, as we discussed before, E is equal to hc over lambda. So simply we can write on here hc over lambda. So I'll be writing here value of Planck's constant, that is 6.63 times 10 to minus 34. C is a constant, that is 3.0 times 10 to 8 divided by lambda of photon, that is 640 nanometers, means 10 to minus 9. So this is energy of photon. Energy of photon, and this value simply we need to plug in here now. So you can copy these values here, 6.64 times 10 to minus 34 multiplied by 3.0 times 10 to 8, and this is divided by 640 times 10 to minus 9. So you can calculate this value here, and then you can solve. You will find value of N will be equal to 1.1 times 10 to 18, means 10 to 18 photons we need for this much energy, means 350 millijoules of energy. So this is the answer. This is how you can approach. This question is also very common in past papers, so you need to understand how to approach this one, because most of the time when students they look at this question, they get confused, they don't know how to approach. So you need to understand what is this energy, what energy is this one, and what is this. So you have to be very clear about this one. If these are clear to you, next time you can handle this type of questions with confidence. Second part says the laser beam is incident normally on a surface that absorbs all of the photons. Show that the force F exerted on the surface by the laser beam is given by F is equal to P over C, where P is the power of the laser beam, is not the momentum, and c is the speed of light. So we can sketch first of all. So imagine this one is the surface, and we can imagine photon like a ball. So this is the photon, it's moving downwards. It has certain momentum just before the surface, so we can say that momentum is p. And now we can take downward as positive. So we can take, actually up is positive, direction of force. So we can say upward force. This is upward direction is positive. So what is the change in momentum? Photon is absorbed. So the final momentum, we can say P final. This one will be equal to 0. So what is the change in momentum? Delta P. That will be equal to 0 minus initial momentum, that is minus P. So it means this is equal to plus P. So this is the change in momentum. So how we can find the force on the photon by the surface? This resultant force, or the average force, this will be equal to delta P over T, means the time at which force is acting on the photon. Delta P over T. So how we calculate momentum of the photon? We have just discussed that momentum of the photon is E divided by C. We have done this one in part A. And how about time? Time, we cannot leave t here like this because t is not in the final answer. So we have to replace t with something. So we have energy. So if I say t is equal to E over P, P is the power. So we have to bring power back. How do I know I have to use this equation for time? Because in the final answer I need power of the laser beam. So we have also discussed this point before. So T is equal to E over P because power is equal to energy over time. Now simply we can plug in these two equations here. So we have, this is E over C, and this is divided by E over P. So we can simplify, we can say this is E over C, and here we have, this is P divided by E. So this E will be cancelled with this E. So simply we will get F is equal to P divided by C. So this is how we can calculate force. So this is the way how you need to answer. When you answer questions in physics, try to understand, try to develop your understanding, because physics is a way of thinking how to answer problems. Part C says light of a single wavelength is incident on the surface of different metals. The work function energy of the metals is given in table 7.1. Explain the term threshold wavelength. Threshold wavelength means maximum value of the wavelength that can cause emission of free electrons from the surface of the metal. Mean electron is emitted from the surface of the metal with zero kinetic energy. That value of wavelength is threshold wavelength. Now let me show you how you can write down your answer. This is how you can write down your answer. In the answer you have to say maximum wavelength of electromagnetic radiation, not maximum wavelength of photon. Maximum wavelength of electromagnetic radiation that causes electrons to be emitted from surface of metal. So this is also important, from surface of metal. You can also say with zero kinetic energy. So if you want to write down in a proper way, if it has 2 marks, you can say with zero kinetic energy. So this is how you need to answer. Second part says for the metals in table 7.1, calculate the value of the largest threshold wavelength. So in order to answer this question, we need to understand that E is equal to Hc over lambda. If this value is the highest, this value means the work function, this has to be the minimum. So this value, because this is E minimum energy of the photon, that is equal to work function. So we have to take the smallest value of work function. So this value we have to take. Then simply we can use the formula that E is equal to Hc over lambda. We need to understand the unit of work function is electron volts, and 1 electron volt, this is equal to 1.60 times 10 to minus 19 joules. This value is given in the data. You can remember this one, or you can find this value in given data. So now simply we can plug in values. E is 2.26 times 1.60 times 10 to minus 19, and value of h, this is Planck's constant, 6.63 times 10 to minus 34, and c is constant, 3.0 times 10 to 8, and value of lambda we need to find out, so we can say this is lambda naught. Now if we solve this one, you will get value of lambda naught means threshold wavelength. This will be equal to 5.50 times 10 to minus 7 meters. So this is the final answer. This is how you need to approach questions from quantum physics. This question is very nice question to practice about quantum physics. If this question makes sense to you, it means most typical questions from past papers you can answer. I hope this video makes sense and this video was helpful and you have better understanding of these exam questions. If these videos are helping, please like and subscribe, and also join Patreon if you are looking for extra resources. And if you have any questions, you can leave in comments and I will try to answer as soon as possible. See you in next video.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 8, Part A says, state what is meant by the binding energy of a nucleus. Binding energy of a nucleus is the minimum amount of energy needed to separate the nucleons of a nucleus to infinity. It simply means that we can imagine we have this nucleus. This nucleus has 2 protons and it has 2 neutrons. The amount of work we need to separate these nucleons to infinity means they are far away from each other. So we can say we have neutron here, we have neutron here. So the amount of work done by the external agent, the minimum amount of work done, that is the binding energy of this nucleus. Now let me show you how you can write down the answer. In the answer you have to mention these points. You have to say that minimum amount of energy required to separate the nucleons of a nucleus to infinity. If you have written this, you will get 2 marks. Part B says a nucleus of uranium-235 absorbs a neutron and becomes unstable. It then undergoes a fission reaction. One possible reaction is shown here. Determine the number of neutrons produced in this fission reaction. So simply we need to understand we have mass number here, we have mass number here, we have mass number here, so we have mass number here. And for neutron, we need to understand neutron has no charge, but its mass number is 1. So simply we can say this is 0, this one is 1. Now if you get mass number, we on left side we have 235 plus 1. This has to be equal to 142 plus 90 plus, we can simply say something has to be here. So this is representing the number of neutrons, and this is possible. Here we will have 236, so here we have 142 plus 90, so we have 132, so this one has to be 4. So 4 neutrons are produced. So simply we can say here 4 neutrons are produced. Second part says data for the binding energies per nucleon for this fission reaction are given in table 8.1. Calculate the energy released in mega electron volts from the fission of one nucleus of uranium-235. Uranium-235. So we have to look at this equation. So in this case we have uranium, so this is a nucleus, and this is individual particle. Individual particles like neutrons, they do not have binding energy attached with them because they are individual particle already, they are not in the nucleus, so they do not have binding energy.
So we have daughter product here, we have daughter product here. These are also individual neutrons, so no binding energy. So I can say no binding energy because they are individual particles, they are not in the nucleus. So you have to be very clear about this. So how we can calculate energy released now if binding energy per nucleon is given to us. So in this case, one thing also you need to understand, in this reaction, if we go this way, binding energy per nucleon, so you have to be very clear. So this point is very important. Listen carefully. Binding energy per nucleon is increasing, but mass is decreasing. So in this case, mass is decreasing. We can also say mass per nucleon is decreasing. Very important point. Mass per nucleon, this decreases. So if the mass is given to us, mass of each nucleus is given to us, so we can calculate energy released by simply using mass defect, energy released. So energy released we can simply calculate by mass defect, means delta m we can calculate and we can multiply with c square, so we can find out energy released. That in this case, mass defect we cannot calculate. We have binding energy per nucleon, so how we can calculate energy released? This question is tricky question and it is very common in recent years, so you have to be very clear how to answer this type of problems. Energy released. So energy released in this case will be equal to total binding energy. So this is the concept. Total binding energy of products, very important one, of products minus total binding energy of parent nuclei. So we can say of parent nucleus. So this is the main concept. Now simply we need to plug in values and we can find the answer. So how we can calculate total binding energy of the product? So here we have mass number 142, so we have 142, and binding energy per nucleon is given 142 is the number of nucleons, and binding energy per nucleon is given to us, that is 8.37. So we multiply with 8.37 plus, so plus we have this nucleus, nucleon number is 90, and binding energy per nucleon is 8.72, so we can write down here 8.72, and minus negative here we have this nucleus, number of nucleons we have 235, so we can say 235, and binding energy per nucleon is given, that is 7.59. So that's all. This is how you need to do. Now if we do simple mathematics, we will get answer in this case 190 mega electron volts. So this is the final answer. So individual nucleon means individual particle, not individual nucleon. There are no individual nucleon. Nucleon means particles in the nucleus. So individual particles, they do not have binding energy. And in any reaction, mass per nucleon decreases, means the mass per nucleon of products is lower, or you can say the total mass of daughter products. But when you are using mass defect, you have to consider the mass of individual particle as well, because we calculate the difference between the total mass of the products and total mass of parent nuclei. So these points you have to be clear how to answer. And in every reaction, binding energy per nucleon of products is greater than binding energy per nucleon of parent nucleus. So if these points are clear to you, you can handle these questions with confidence. Third part says the isotope xenon 142 is unstable. The isotope xenon 132 is stable. Suggest a reason why xenon 142 is unstable. As these are isotope of the same element, it means that they have same number of protons. As this one has a higher mass number, it means this one has more neutrons. So as the ratio between neutron to proton increase, isotopes become more unstable. So simply we can say the ratio between neutron and proton is higher for xenon 142. So that's reason 142 is unstable. So for the answer of this question, simply you can say its neutron to proton ratio is too high. So this is unstable. Part 4 says xenon 142 decays into the isotope cesium 142. A sample initially contains only nuclei of xenon 142. After a time equal to 6.0 seconds, the ratio between the number of decayed nuclei of xenon 142 and number of undecayed nuclei of xenon 142 is equal to 31. Calculate the half-life of xenon 142. Show your working. This question is straightforward, and also this question is very tricky if your basic concepts are not clear to you. First of all, when some student they will look at this question, they will just understand, they will interpret this one like this, that n over n naught, this is equal to 31, and then they will use the formula, that n is equal to n naught e to the power of minus lambda t, and they will try to figure out value of half-life. Lambda in this case is decay constant. They have this misconception because actually they don't understand what this n is representing. This n is a function of time actually. So this gives us remaining nuclei at any given time, or we can say this is giving us undecayed nuclei. Number of undecayed nuclei at given time. Number of undecayed nuclei at given time t. T is the given time. And what this n is representing, this is initial number of nuclei, means in the sample, total number of nuclei in the sample. So we can say initial number of nuclei. Now you have understanding of this formula, so you will not use n over n naught is equal to 31, because that is wrong, because this is giving number of undecayed nuclei. This is number of total nuclei, and that is not here, so we need number of decayed nuclei. So you will not use this one. Now your concept is clear. Now we will proceed to find the answer of this question. So we can write on here, first of all, number of decayed nuclei. So if you have the total number of nuclei n naught, and remaining nuclei we have n, so this will be decayed nuclei. Undecayed nuclei we have already said this is n, and this is equal to 31. I hope this makes sense. Now we can simplify this one, so we can say in this case n naught minus n, this will be equal to 31 times n. So from here we can say n naught, for example, this minus n will be positive here, so we will get 31 plus 1, it means this will be equal to 32n. So now we got here n over, so here we got n naught by n, this is equal to 32, or we can say n over n naught, this is equal to 1 over 32. So this is here. Now simply you have to use this formula. So let me write down here. So now we have n over n naught. So here we have n over n naught, that is equal to 1 over 32. And this is equal to e to the power of minus lambda t. Lambda is a decay constant. We need to calculate half-life. So the lambda will be equal to ln 2 ln 2 divided by half-life t1 by 2. So this is how you can calculate decay constant. So now we can simply say we have 1 over 32. So here we have 1 over 32, means this one we replace with this, and this is equal to e to the power of, here we have ln 2, this is divided by t half-life, so t1 by 2 multiply with t, so this is the time given 6 seconds, so here we have negative. Now if we take ln on both sides, ln here means ln here, so let me write on here, we have ln, here we have 132, and if we take ln here, so you can rewrite this one. So I'll just write down directly, if you take ln, what you will get here, if you take ln, you will get this is minus, ln is 1, so that will be cancelled, so we will have ln 2 and multiply by 6. So we can say this will be minus 6 ln 2 divided by t half life, t 1 by 2. So this side what we will get, minus we will get, this is ln 32 because this is 32 here, so the power is minus 1, so minus 1 will come in front of ln, so we will say minus ln 32. This is equal to minus 6 ln 2, this is divided by t1 by 2, means the half-life. So negative negative will be cancelled, so these two will be cancelled. Now we can write on here, so we have t half-life, so we can say t1 by 2, this will be equal to 6, and here we will have ln 2 divided by ln 32, so here ln 32. So we have 6, so t32, so this is divided, and if you solve this one, so this will be 1 over 5, so this will be here, let me write on here, so here you will get 6 and this will be 1 over 5, so it means this is 5, and the final answer t half-life, mean half-life in this case will be equal to 1.2 second, and your final answer will be equal to 1.2 second. So this is how you need to approach. So understanding of this one is very important. You need to understand meaning of each quantity. I hope this question makes sense. If these videos are helpful, they are helping you to improve your understanding of physics, please like and subscribe. And also if you have any questions, you can leave your questions in comments, and I will try to answer as soon as possible. And if you're looking for extra resources, join Patreon. On Patreon you will see more resources. See you next video.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2024, Paper 4, Variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of physics, and also you can have better understanding of these exam questions. Let's study together, let's improve together. Question 9, part A says, electrons in a vacuum are accelerated through a potential difference of 84 kilovolts. The electrons then strike a metal target and X-rays are produced. Calculate the minimum wavelength of the X-rays that are produced. Minimum wavelength means that the total kinetic energy has been converted into energy of X-ray photon, and total kinetic energy is equal to the electrical energy. So simply you can start from here. We can say Q times delta V. The gain in kinetic energy is equal to the electrical energy supplied, and this is electrical energy supplied, and this is equal to energy of X-ray photon. So this is energy of single photon, and this is energy gained by single electron. So we need to find out value of lambda. So we can say lambda minimum in this case will be equal to Hc over Q times delta V. Value of H is a Planck's constant, that is equal to 6.63 times 10 to minus 34, and C is a constant, that is equal to 3.0 times 10 to 8. These two constants are very important for quantum physics. And Q is the charge on single electron, 1.6 times 10 to minus 19 coulombs, and delta V is the potential difference, that is equal to 84 kilovolts. Now if we simplify, in this case we will get 1.5 times 10 to minus 11 meters. So this is the minimum wavelength. So if you have done this one, you will get 2 marks for this question. Second part says the melting points of two metals are given in table 9.1. Copper melting point is given and tungsten melting point is given. Suggest why the metal target is made from tungsten rather than copper. Because melting point of tungsten is much higher than melting point of copper, and during X-ray a lot of energy is converted into thermal energy. About 99% energy is converted into thermal energy, means the kinetic energy of electrons is converted into thermal energy, and this is roughly 99%. So only 1%
kinetic energy of electron is converted into X-ray photon. So we need metal with a higher melting point. That's the reason we use tungsten. Now let me show you the answer, how you can write down the answer. So this is how you can write down the answer. This question has 2 marks. So first mark, you can say some kinetic energy of electrons is converted into thermal energy at target absorbed by tungsten. Tungsten does not melt quickly because it has a higher melting point. So if you write on these 2 points, you will get 2 marks. Part B says an X-ray beam is incident normally on a sample of soft tissue and bone as shown in figure 9.1. Data for the 2 materials are given in table 9.2. So we have value of attenuation coefficient and also we have values of specific acoustic impedance. The total thickness of soft tissue is X. Total thickness of bone is also X. The incident intensity of the X-ray beam is I naught. The transmitted intensity of X-ray beam is 13% of the incident intensity. Determine X in centimeters. So how we can answer this question? The simpler way to answer this question is, first of all, simply we can combine soft tissue. So here, so we can combine here. So this is representing soft tissues and here we have the bone. So this second part is the bone. So this is soft tissue, so we can write on here. So here we have soft tissue and this one is representing bone. Thickness of this one is X, so this thickness is given. This thickness is X and this thickness is also X. So here we have intensity, this is I naught. At this point, let's say intensity become I1 and here intensity is I2. In the question it is given to us that I2 is equal to 13% of I naught. So here we have I naught. So it simply means that I2 is equal to 0.13, 1 theory, or you can say 13 divided by 100 I naught. So we can say I2 divided by I naught. This is equal to 0.1 theory. Now first of all, if you look at soft tissue, for this one we can write down I1 over I naught. This one will be equal to e to the power of negative mu x. So here we have mu x. So we can say this is mu 1. So at this point we can say I1, this one will be equal to I naught e to the power of negative mu x. Even you can just start with this one. So we have I1 here. And at this point I2 we can write down. I2 will be equal to intensity at this point. In this case we are talking about X-rays, so we ignore reflection. So here we have I1, this is equal to e to the power of mu 2 times x. Now this I1 we can replace with this value I1. So I1 we can write down, this is I naught e to the power of negative mu 1 x. And here we have e to the power of negative mu 2 x. I2 by I naught we have here. So we have here. And we can write down this here. We have a little bit more space. So we can say I naught by I2. Actually, this is I2. We have I2 divided by I naught. This is equal to 0.13. So you can even clear this part. So if you want to clear, you can clear this one. So let me clear this. So this is I2 by I naught, and this is equal to e to the power of negative mu 1. We have 0.22, this is 0.22 x, and here we have e to the power of negative 3.0 times x. So we need to find out value of x from here. Value of x. So this is e to the power. So simply we can say this is 0.13. Here we have e to the power. We can combine these two. We will get 3.22 x. Now if we take ln on both sides, so we can take ln of 0.13. So here we will have ln of e. So we will have minus 3.22 x. So x from here will be equal to ln 0.13 divided by, we have negative 3.22, and we will get our final answer, that will be equal to 0.63 centimeters, because the unit of mu is centimeter. So this is our final answer. This is how you can calculate. C1 says define the specific acoustic impedance of a medium. Acoustic impedance, simply Z is equal to rho times C. Rho is the density of the medium, so you need to understand this is density of the medium, and C is the speed of ultrasound in that medium. So this is speed of ultrasound in that medium, and the product of these two quantities is called specific acoustic impedance. Now let me show you the answer, how you can write down the answer. For the answer of this question, simply you can say product of density and speed of ultrasound in medium. Second part says use data from table 9.2 to calculate the percentage of the intensity of ultrasound that is transmitted at a boundary between a soft tissue and bone. So for this purpose, simply we can draw first of all. So you can take any boundary between soft tissue. So this is soft tissue, and here we have the bone. So this one is the bone. So we can take any boundary. Let's say we take this boundary, and we assume at this point intensity is I naught. So this is the intensity I naught. From here IR will be reflected, so we can say this is IR, and IT will be transmitted. So this will be IT. So IT will be transmitted. We need to calculate fraction transmitted. So we can say fraction transmitted. This is what we need to calculate. Fraction transmitted. Fraction transmitted will be equal to 1.0 minus fraction reflected. Fraction reflected. This is based on conservation of energy. So this is fraction reflected. So if we can calculate fraction reflected, so we can find out fraction transmitted. And if we have fraction transmitted, then we can find out percentage transmitted. So simply we can find out percentage transmitted. That will be equal to fraction transmitted. So this is how you need to answer the question. Fraction transmitted time 100. So this will be time 100. So we can find out percentage. So we need to work out fraction transmitted, fraction reflected. So we need fraction reflected, and fraction reflected means this is equal to IR over I naught. This one will be equal to Z1 minus Z2, Z1 minus Z2 square over Z1 plus Z2 square. So this is acoustic impedance of medium. So we have Z1 in this case. So Z1 we are taking this value bigger, and this is Z2. It doesn't matter which one you take, Z1, which one you take Z2, result will be the same because we have square here. So we have Z1 that is equal to 7.8 minus we have 1.7 square of this divided by we have 7.8 plus we have 1.7 square of this. Now if we solve this one, we will get 0.41. So means 41% is reflected, so 59% will be transmitted. So we can get this is, so we will get here, so this is 1.0 minus we have 0.41, so we will get 0.59. So if we multiply 0.59 with 100, so we will get 59%. So this is 59%. So simply we can say this is 59. So this is how you need to answer this question. So one thing more you need to understand is that 1 is equal to IR over I naught for your better understanding, plus this is IT over I naught. So if you take LCM from here, for example, you will take this is I naught, so this is IR plus IT. So it means IR plus IT, this is also equal to I naught. So here, so intensity here you can say incident is equal to IR plus IT. Third part says the ultrasound is now incident on a sample of soft tissue and bone shown in figure 9.1. Suggests two reasons why the transmitted intensity through the sample is less than the answer in C2. In C2 we have found fraction transmitted. In the last part, in the second part, we have found that fraction transmitted is equal to 0.59. Fraction transmitted is equal to 0.59. And in that case we have just considered one boundary. So we said this is the soft tissue and here is the bone. We just considered one boundary. So this is the point you need to understand. So in this case we just considered this one boundary. So let me change color so you can understand this one better. So we consider just one boundary, mean this one boundary we considered. But if you look at this one, here we have more than one boundary. So you can see we have one boundary here, we have one boundary here. So it means here we have more reflections. So we can say more reflections. If more reflections, it means that transmitted intensity, this intensity will go down. So this is one reason. The second reason is when ultrasound waves, they pass through the medium, some of ultrasound waves, they will be absorbed. So ultrasound will be attenuated. So you can say the second reason. One reason, more reflections. Second, you can say absorption. So this can be the second reason, absorption in soft tissue and bone. So these two reasons you can write on. This answer need two reasons. Now let me show you the answer, how you can write down the answer. In the answer you can mention these 2 points, more than one boundary, so more reflections, so transmitted intensity will be lower, and some ultrasound is absorbed in the soft tissue and bone. You can also say in the matter. Matter means soft tissue and bone. Question 10 part A says the sun has a surface temperature of 5780 kelvins. The luminosity of the sun is 3.85 times 10 to 26 watts. Calculate the radius of the sun. So simply we have to use Stephen-Boltzmann law. According to Stephen-Boltzmann law, luminosity is equal to sigma A. A is the surface area times T to the power of 4. This is absolute temperature. So we need to find the radius. We can write down the surface area. This is 4 pi r square times T to the power of 4. We need to find out r, so we can say this will be equal to L divided by sigma 4 pi times T to the power of 4. And we need to take square root of this. Now simply plug in values and you will be able to find the answer. Luminosity is 3.85 times 10 to 26, and this is divided by sigma. Sigma is 5.67 times 10 to minus 8, and here we have 4 pi, and temperature we have already in Kelvin. This has to be in Kelvin. So we have 5780. If we take root of this one, we will get value of R. R will be equal to 6.96 times 10 to 8 meters. So this one is the radius of the sun. So we can write on here 6.96 times 10 to 8 meters. Just little typo here. So the power of this one is 4, because here we have 4, so power here also has to be 4. Second part says the earth is a distance of 1.50 times 10 to 11 meters from the sun. Calculate the radiant flux intensity F of the radiation from the sun at a distance of 1.50 times 10 to 11 meters. Give a unit with your answer. So simply we need to calculate radiant flux intensity, that is F, and F is equal to power over surface area. So this is equal to power over surface area of that sphere. So we can simply write down A. So power in this case is the luminosity, and here we have this is 4 pi t square. Let me explain you a little bit this one in detail. So in this case what we are saying is that D is the distance from center to here. So this sun is located here and our planet is located here, so at this point. So this D is the distance, and luminosity of the sun is here, means the energy emitted per second by the sun, that we have in the last part, and that was equal to 3.85 times 10 to 26 watts. Now simply we need to plug in values and we can find value of F. So this is 3.85 times 10 to 26 divided by, we have 4 pi times, we have 1.50. D is 1.50. So we can plug in here 1.50 times 10 to 11 square of this quantity. And if we simplify this one, we will get 1.36 times 10 to 3 watts, and unit of distance is meter square, so per meter square. So we can write on here 1.36 times 10 to 3 watts per square meter. So the power of luminosity is watt, power of distance is meter. So this is simply how you need to answer. Third part says the variation with wavelength of the intensity of radiation emitted from the sun is shown in figure 10.1. Another star has the same radius as the sun but has a lower surface temperature. On figure 10.1, sketch a line to show the variation with wavelength of the intensity of radiation emitted for this star. So first of all, we can look at the luminosity of the star. Luminosity is equal to sigma 4 pi r square times t to the power of 4. Radius is the same, surface temperature is lower, it means luminosity is lower. Now we can determine the wavelength, peak wavelength, by Wien's displacement law. So we can say Wien's law I'm writing, so you can say Wien's displacement law, lambda peak times surface temperature. So this is surface temperature, you have to be clear about this one. This is equal to constant, so the product is equal to constant. If surface temperature go down, it means this lambda, as luminosity is lower, so it means intensity is also lower, means lambda is longer, so intensity is also lower. Now we need to sketch the curve. Before we sketch the curve, let me show you this figure. Understanding of this figure is important, so you can see the trend here. When lambda is longer, how about intensity? So you can see as lambda is getting longer, peak intensity is decreasing. So you can see here peak intensity is decreasing. So this is the main concept you need to understand, that lambda peak times T surface temperature, this is equal to constant, and this is based on Wien's displacement law. And based on this one we need to sketch the curve now. So we can draw the line here. So this is peak, so the next peak has to be lower and it has to be at longer wavelength. So it has to be somewhat like this, high, means longer wavelength. And now simply we can connect this, it has to be always lower. So this is how you can sketch the curve, and if you have drawn this one you will get 2 marks. Wavelength has to be longer and the peak intensity has to be lower. Part B says a galaxy in the constellation Corona Borealis is moving away from the Earth. The visible emission spectrum for the sun is shown in figure 10.2. The lines are at wavelengths of 397, 410, 434, 486 and 656 nanometers. The compositions of the sun and a star in the Corona Borealis galaxy are similar. On figure 10.3, sketch the emission spectrum for the star in the Corona Borealis galaxy as observed from the Earth. No calculations are required. Sketch the emission spectrum. I mean, these lines simply you need to sketch. So in this case here we have 350 and this is 400. So it means it is divided into 5 equal parts and one part is representing 10. So this is 397. So it means this has to be very close to 400. Very close to 400. So I can simply draw the line here. So you need to draw the line here. So this is. Next one is 410. So 1/5 of this total, this distance, you have to divide into 5 equal parts, and one part is 10. So we can draw about here. So this is just about is quite enough. Next one is 434. So 400, 450, 425 is halfway. So I'm assuming this is about a halfway here. So I can draw a little bit next to this one. So it has to be little after half. Little after half. So we can draw, this is about 1/5. So it will be little bit here. So this is 486. 486 means here. So this has to be here. So you have to be a little bit careful with this, but just approximate is okay. You can use meter rule and you can find 1/5 around here. 656. So this is 650. So again 656, it will be around here at this point. So this is how you need to draw these lines. You can use meter rule actually, and you can draw them in a proper way. I've just drawn approximate locations. Second part says the galaxy in Corona Borealis is moving away from the Earth at a speed of 21,400 kilometers per second. Use information from B1 to calculate in nanometers the observed wavelength of the lowest visible energy emission for the star in the Corona Borealis galaxy. Lowest visible energy. Lowest visible energy, so E minimum, it means that we have to consider the maximum value from the visible energy spectrum, lambda max. And also galaxy is moving away, so even lambda will increase. So we can say the value of lambda will be equal to the lambda max plus change in wavelength due to redshift. So we can say delta lambda. Lambda max from part B1 we have that was equal to 656 nanometers plus delta lambda. So this value we need. Delta lambda simply we can calculate. This is delta lambda over lambda is equal to V over C. Delta lambda will be equal to V times lambda divided by C. V is 21,400 kilometers per second. So you have to multiply by 1000. So this is meters per second divided by C, that is 3 times 10 to 8 meters per second multiplied by lambda, that is 656 nanometers. So you no need to convert unit here because this meter per second will be cancelled, so unit is nanometer. Now if we solve this one, we will get 46.8 nanometers. 46.8 nanometers. So simply we can write on here 46.8 nanometers. So if we solve this one, our answer is up to 3SF 703. So this is how we can answer the question. So you need to understand what question is asking you, and then look at the given informations and try to use your understanding of physics to reach the final answer. Third part says the wavelength in B2 is used to calculate a value for the surface temperature of the star in the Corona Borealis galaxy. The calculation does not give an accurate value. State and explain whether this value of temperature is too high or too low. First of all, we need to understand the value of lambda we have calculated in the last part. That value is the maximum value. And that maximum value actually is not the peak value. So we can say it's not equal to the lambda peak of intensity against lambda curve. As lambda max, what we have calculated in the last part, that is greater than lambda peak, actual value of lambda peak, by Wien's displacement law. So we can say lambda peak times surface temperature. So here we will say surface temperature. This one has to be equal to constant. So if we assume lambda p is equal to lambda max, for example, this value will be very high. We're using the maximum possible value of lambda. So it means this temperature, surface temperature of the star, based on this calculation, has to be very low. So this one point simply you need to write down. So how we can write down the answer? For the answer, we can simply say peak wavelength too high, means we are saying this is peak wavelength. We are using this value for the peak wavelength, so temperature will be too low. So if you say temperature will be low because peak wavelength is too high, you will get 1 mark. That's all for today's lesson and also for this paper. I hope these videos are helpful and these videos are helping you to improve your understanding of physics. If this is the case, so please like and subscribe, because your encouragement is very important. And if you're looking for extra resources, you can also join Patreon. On Patreon you will see more resources, not only video, a lot more than videos. See you next video.